Good morning, students. Today we are going to discuss about energy levels of a particle enclosed in one-dimensional potential box of infinite height. So energy levels of a particle. Energy levels of a particle enclosed in one-dimensional potential box. Here we are discussing about energy levels of a particle enclosed in one-dimensional potential box. Here two walls A and B. These are two rigid walls. A is a point at x is equal to 0 and B is another point at x is equal to A. The distance between the two walls is A. Consider a particle of mass m. Consider here a particle of mass m. It is free to move between the two rigid walls. Suppose the particle of mass m is moving towards the wall B and it strikes the wall and reflects back towards another wall. Because if there is no force on the particle, it is free to move. The potential energy of the particle is constant. The potential energy of the particle is constant because there is no force acting on the particle. If it reflects back and it strikes another wall A. So, in this way, the particle is moving between these two walls. The walls are perfectly rigid so that the particle cannot penetrate through the walls. As the walls are perfectly rigid, the particle cannot penetrate through the walls. These walls, A is at a point x is equal to 0 and B is at a point x is equal to A. Why this is one-dimensional potential box? Because we are considering that particle is moving in one dimension, so that we call it as a one-dimensional potential box. Generally, a box has three-dimensional, just like space. So we are talking about one-dimensional box means this particle is moving only along x-axis, so that it is considered as one-dimensional potential box. It is infinite height. That means this height cannot measure. Let it be considered the walls of infinite height. Topic is energy levels of a particle enclosed in between two walls of infinite height. Okay. Now the potential energy of the particle, potential function can be considered as V of x is equal to infinite when x is less than 0 and x is greater than a, then the function becomes infinity. Potential energy is infinity. V of x is equal to 0 when the particle is in between x and a. So potential energy when it is infinite, when the particle is beyond the walls. That means x is less than 0, x is greater than a. If it has infinite potential energy, then only it penetrates through the walls. Here in this case, it has no penetrating power. So that if it has infinite potential energy, then only it can go beyond the walls. So V of x is equal to infinity. For simplicity, there is no force acting on the particle. Force is constant, potential energy is constant. We are considering that potential energy is equal to 0. So this is equation number 1. Then Schrodinger wave equation. We know that the Schrodinger wave equation. So del square psi plus 2m by h cut square to e minus v into psi is equal to 0. Here in this case, particle is moving only one direction. So the Schrodinger wave equation is like this: d square psi by dx square plus 8 pi square m by h square into e minus v into psi is equal to 0. Here the potential energy is 0. By substituting v is equal to 0, then the equation d square psi by dx square plus 8 pi square m by h square into e minus 0 into psi is equal to e psi is equal to 0. Okay. This is equation number 2. This is Schrodinger wave equation. In this equation, see this 8 pi square m by h square into e. This is equal to k square. K square is equal to 8 pi square m by h square into e. If we substitute k square value in the equation 2, then equation 2 becomes d square psi by dx square plus k square psi. This is a differential equation in the second order form. The solution of this equation, this is equation 3. The solution of this equation is in the form of sin kx or otherwise cos kx. Let it be psi of x. The solution of the equation 3 is equal to psi of x is equal to a sin kx plus b cos kx. This is the solution of the equation 3. Let it be 4. Here a and b are two constants. These values are obtained by applying the boundary conditions. Here the boundary conditions are the psi of x is equal to 0 at x is equal to 0 and psi of x is equal to 0 at x is equal to a. At the boundaries, the function is 0. By applying the two boundary conditions, we can get the values of these constants a and b. So, apply first boundary condition. What is that? Applying first boundary condition. First boundary condition is psi of x is equal to 0 when x is equal to 0. So, psi of x is equal to 0 is equal to a sin k into 0 is a sin 0. That means a sin 0 plus b cos k into 0, cos 0. Here sin 0 is 0, cos 0 is equal to 1. This implies b is equal to 0. One constant b is equal to 0. Now let us find the another constant a. Now the equation psi of x is equal to, here in this equation b is the 0, this term, the complete term is 0. Now only a sin kx. Psi of x is equal to a sin kx. Now apply second boundary condition. Applying second boundary condition. Second boundary condition enti psi of x is equal to 0 when x is equal to a. Psi of x is equal to 0 when x is equal to a. Okay. Psi of x is equal to 0 when x is equal to a is the second boundary condition. Okay. Apply the second boundary condition in this equation. Left side psi of x is equal to 0 and right side x is equal to a sin ka. Here 0 is equal to a sin ka. 0 is equal to a sin ka means a sin ka. చూస్తే ఈక్వేషన్ అబ్జర్వ్ చేస్తే either a 0 or otherwise sin ka is 0. If a is equal to 0, that means the two constants a and b, if these two constants are 0, that means entire function will not exist. So a should not be 0. Sin ka must be 0. In this equation 0 is equal to a into sin ka. ఎప్పుడు 0 అవుతుంది? ఏ కానీ sin a ka కానీ ఈ రెండిట్లో ఏదో ఒకటి 0 అవ్వాలి. ఏ 0 అవడానికి పాసిబిలిటీ లేదు కాబట్టి sin ka అనేది 0 అవుతుంది. sin ka is equal to 0. sin ka is equal to 0. sin ka ఎప్పుడు 0 అవుతుంది? sin ka when sin ka is equal to sin n pi, then only ka is equal to 0. Here sin pi is 0, sin 2 pi, 3 pi and so on up to sin n pi is equal to 0. Here sin ka is equal to sin n pi, then ka is equal to n pi. This implies k is equal to n pi by a. K is equal to n pi by a. From this, the wave function psi of x is equal to a sin kx. A sin k means n pi by a into x. Now discuss about eigenvalues. Here k is equal to n pi by a. K square is equal to n square pi square by a square. ఇంతకుముందు ఈక్వేషన్లో k square is equal to 8 pi square m by h square into e. This is from Schrodinger wave equation and this k square is obtained. These two values k squares are equal. Equate these two values from this. 8 pi square m by h square into E, let it be suffix n. E suffix n means the energy of nth level is equal to n square pi square by h square. From this equation, En is equal to pi square gets cancelled. N square into h square by n square h square, here a square, n square h square by 8m a square. E suffix n is the energy of nth level. Here n is equal to 1. If n is equal to 1, E1 is equal to if n is equal to 1, E1 is equal to 1 square, 1 into 1 square into h square by 8ma square. That means E1 is equal to h square by 8ma square. If n is equal to 2, E2 is equal to, here n is equal to 2, so 2 square, 4 h square by 8ma square, means 4 into E1. If n is equal to 3, then E3 is equal to 9E1. If n is equal to 4, E4 is equal to 16E1. In this way, you can draw the energy level diagram of particle in one dimensional. Particle in one dimensional. The energy levels of nth energy levels is equal to n square h square by 8ma square. From this, you can draw the energy level diagram. In this equation, wave function psi of x is equal to a sin n pi by a into x. Here the a value is, now calculate the a value. Wave function can be obtained by determining the value of a. Then only you can write the wave functions. How can we calculate a? Take normalization condition. If psi is the wave function, mod psi square into integral mod psi square into dx is equal to 1. This is the normalization condition. Normalization means the probability of finding the particle is unity. If there is the probability of finding the particle, then the probability is equal to 1. Here, integration from 0 to a. The distance between the two walls is 0 to a. So, integration is also from 0 to a. Psi of x means a sin n pi by a into x. Psi square means a square sin square n pi x by A into dx. This is equal to 1. By taking normalization condition, you can calculate the A value. Here, A square is constant. A square integral sin square x dx 1 minus 1 by 2 of 1 minus cos 2x cos 2 into n pi by a into x into dx is equal to 1. A square is integral a square by 2 integration of 1 into dx is x. Integral cos x is sin n pi x by a into a by 2n pi from 0 to a. This is equal to 1. Here by applying limits, when we apply 0, x is equal to 0. When we apply x, a, here a square a by 2 is equal to 1. The sine function becomes 0 by applying limits, lower limit and upper limit. This is from this a square is equal to 2 by a and a is equal to square root of 2 by a. Then we can write the wave function. Psi of x is equal to, the wave function psi of x is equal to a is root 2 by a. A is equal to root 2 by a. Then sin n pi by a into x. This is the wave function. Suppose if n is equal to 1, psi of x is psi 1, wave function psi 1. If n is equal to 2, then the wave function psi 2 and so on. From this, the wave functions you can write by knowing the n values. In this lesson, we discussed about the energy levels of a particle in one-dimensional potential box of infinite height. Consider a particle of mass m. This is inside the walls and it moves along only x-axis. So this is considered as one-dimensional potential box. The energy levels E sub x n is equal to n square h square by 8 ma square. Here n is the number of energy level, h is Planck's constant, m is the mass of the particle. Suppose if the particle is electron, take the mass of the electron. If the particle is proton, take mass of the proton. Then A is the distance between the two walls. Okay, so this is the formula is important for problems also. If any problem is asked like this, if n, m and a values are given, then we can find the energy of that particular nth level. Okay, thank you.